Accommodation. Ever wondered how you are able to see an object which is near you, and without moving, you are still able to see an object which is very far from you without moving? It means your eyes are able to perceive something that is next to you, not far from you, and something that is far from you. So that happens because of the phenomenon we call, or we refer to as, accommodation. I'm sure the first time you heard the word accommodation, you thought maybe they were talking about you moving out and moving to a new flat or something, or relocating. No, that's not what it means. Accommodation is the ability of the eye to change its focus from distant to near objects and vice versa. It means that your eyes have that ability to look at an object and see clearly when it's near you, and to look at an object at the same time also and see clearly when it's far from you. So that is the ability that the eye has. How the eye does it, we are going to look at it just now. Before we get into the process of accommodation, let us do some preparation. First, let me take you through a phenomenon we refer to as refraction. I'm sure you've witnessed this kind of situation before, where you have, for example, a spoon inside a glass of water, but then you see as if the spoon is bent. Look at that. It's as if the spoon is totally detached from itself. It's kind of bent. That's what we observe when we have this kind of situation. Now, what's happening here is because the light that you're seeing, the light that you're perceiving coming from the spoon to your eyes, because when you look at an object, it doesn't mean that now you're looking at the object and the light is coming from your eyes and going towards the object like Superman. No. Light actually leaves from the object and goes to your eyes. That's how it happens when you're looking at an object. So then, when you have, like in this case, a spoon in a glass of water, the reason why you see it bent like this, or completely detached, doesn't have a clear form anymore, is because of the phenomenon we refer to as refraction. And then refraction is the bending of light waves as it travels from one medium could be glass, for example, to another medium, for example, water, of different refractive indices. Light, if I should ask you, can light pass through glass? The answer is yes. Can light pass through clear water? The answer is yes. Can light pass through air? The answer is yes. Now I've mentioned three things. I've mentioned glass, water, and air. These are what we refer to as media, singular, medium. The word medium can then be used for many different things, depending on the context. In this context, a medium is simply like an environment or a kind of material or substance. So I have three media: glass, water, and air. Now, since we agreed that light can pass through all these three different media, the other question is, do you think light will travel in air the same way as it travels in water, the same way as it travels in glass, for example? The answer is no. Light will travel through them, yes, but in different ways, or better put, at different speeds. Light will travel, for example, very fast in air, but slowly in water. Hence, due to that difference in speed, when light now is leaving from air to water, we expect that the light will behave differently. The straight line that the light tried to keep will somehow have to alter, will somehow have to bend. So all these scenarios we've seen here are as a result of refraction. We've seen that. Like I was saying, when you're looking at an object, light is coming from that object to your eyes. It means, if we look, for example, in this case here, I have here water, I have air, for example. When I'm looking at the tip of this pencil, light would have to leave from water and pass through air to reach my eye. But because of the difference in the way the light travels in these different media, the light rays cannot be straight. That's why it will have to bend. Will have to bend. So when light leaves the water, the moment we reach at that interface, the surface between water and air, as the light exits, the light will bend. And since the light bends, remember we see objects as a result of the light that they reflect. So all the light will be bending, will be reflected from that object there, and then it will have to come into the eye like that. Okay, that's the eye viewing there. Now, so in simple terms, the eye takes what it gets. It means if my light rays were straight coming to the eye, then that pencil here would be straight at all times. If my light rays are bent coming to the eye, then just like we see in the diagram here, the pencil itself will be bent as a result of that. So the same happens with the spoon. Because the light doesn't come all the way straight from bottom to the air interface, because the light bends, then the object will also appear bent to the eye. The same also happens here. Because the light bends, doesn't go straight, then the pencil's tip position would even change also because of that bending. Now, what causes that bending? That bending is caused as a result of the difference in the properties of this media. And how do we call that bending? Which is caused by this difference in properties. That bending is what we refer to as refraction. That's what refraction is. Let's look at more examples. Imagine we have a coin. This is a coin here. We have a coin under a glass. This, let's say this is a beaker, and it contains water. And I'm trying to view that coin. I'm trying to see it. I'm trying to view it passing through the glass, the water, and to the coin. Now, I'm sure I can still see that coin, yes, but even if the water here was black, such that light cannot even pass through, such that we can see the coin, at least the women will still see that money. Okay, as far as there's money concerned, women will always see where it's hidden. Now, that aside, when we are viewing this coin here, I want you to notice something. Light would have to travel from the coin, pass through glass. This is glass. The light will have to pass through water. This is water. The light is passing through water. The light again is passing through glass. This is again glass. And before it reaches the eyes, it will have to pass through air. This is air. So, how many different media do we have in this picture in the path of light? How many different media? We don't have 4, we have 3, because glass is the same as glass. Okay, we have 3 media. The second question is, do you think the light will travel the same way as it travels through all the media? Do you think the light will travel the same way in all the media? The answer is no. Because when the light at each interface, the light will bend. The light will obviously bend. So then, when the light is exiting when it's passing through the glass, the moment it's exiting from the glass to the water, it will somehow bend. And as it's going in the water, it will somehow bend again in the glass. As it's going in the air, it will again bend. This is what would result sometimes when we're looking at a coin in this kind of situation. Sometimes the position of the coin itself shifts such that we see the coin will appear somewhere, say here. That's where we'll be seeing that coin. And if we send our hands inside that container, we'll struggle to pick up that coin until we start confessing, because we'll never be able to pick it up. Okay, the position of the image has changed, but the object is still where it was. That's not moved. It means if we're trying to grab this coin here, if we try to grab this coin here, we will never grab it, because it's just an image that has formed and it has shifted from the position of the object itself thanks to the phenomenon we refer to as refraction. So that's how refraction occurs. Let us now link refraction with how we see with the eye. Light rays coming from any object that we are viewing would enter the eye and would want to be brought always to a focus on the retina. Remember, it is the retina that has the photoreceptors, the rods and cones. They are the ones that are able to trap the light stimulus and convert it to impulse before it is being sent through the optic nerve to the cerebrum, such that we can then see any object. So again, for that to happen, light needs to enter the eye and reach the retina. It means that whatever the eye does, its main mission is to make sure that light is brought to a focus on the retina. However it takes, however it can happen, light needs to reach that focus on the retina. But then as light is passing through, let's see what this light is passing through. I just gave here some wild names, which doesn't exactly mean what it is, but so that we can see, we can link it up with the phenomenon of refraction. As light is passing through, let's look. First, it passes through air. This environment here will be air. It's coming from the object through air. And the first time it makes contact with your eye, it first makes contact with the cornea. That part there, that will be the cornea. It makes contact with the cornea. And the cornea, I've compared the cornea to glass. That's what I've compared it to. I'm sure we can now start seeing something. It's like we are moving from air to glass. What do you think will happen? Light will bend as a result of what? Refraction. Now, when we leave the cornea, we will enter this first chamber that we refer to as the aqueous humor. It's basically filled up with water. It means we have now left from glass to water. What will happen? The media, are they the same? The answer is no. The media are different. So what will happen to the light? The light will bend as a result of refraction. From here, from the aqueous humor, we are now going to pass through the lens. The lens also basically contains water. Again, the light will just continue passing through because we left from water to water. And we go again, we're going to pass another chamber, which is the vitreous humor, which again we'll say is essentially made up of water. Again, the light will continue. And all of these, we have moved from air to glass to water. All of these will contribute such that that light will bend and be brought to a focus, to a pinpoint on the retina, and then the light stimulus can then be interpreted and converted to a stimulus, to an impulse, that will be sent through the optic nerve. So that's basically what happens. I want you then to realize that the eye as it stands is well equipped with different material that can refract or that can bend light such that it is always brought to a focus on the retina. If we look at the light that's here, we'll see that it somehow entered straight and somehow it's been bent. Goes straight and bent. What causes that bending? By now we should all be clear to know that the bending is caused as a result of refraction. I'm sure at first when you used to see diagrams of the eye always viewing with light being bent like this, surely you would wonder what exactly is happening. Today we've unlocked that mystery. We now know that the bending of that light is as a result of refraction. Why? Because light is traveling through different media. Hence, it will bend, as we saw in all the diagrams that we've been having. Now, accommodation. Back to accommodation. The process by which the eye is able to see objects or to bring images of light from objects that are either far or near to a focus always. That's our accommodation. How will it then do that? In either ways, whether it's from a far object or a near object, light will always need to be refracted or bent so that it can reach that focus on the retina. For that to happen, something needs to change. We need to change the amount of water, for example, present. Now let us restrict this to the eye alone. When we're looking at the eye alone, we are having glass, water, water, and water here. Looking at just where we have water, we have three places. We have at the aqueous humor, let me call that number 1. We have in the lens, call that number 2, and we have in the vitreous humor, that will be number 3. So sometimes we'll need that amount of water to change. And the place where we are looking at where the change would have to be mostly would be at the level of the lens. So it doesn't mean that you'll have to either refill your eye with water or pour out some water from your eye each time you want to view distant or near object. No. The simple thing that happens is a trick that the eye plays using its lens. The water in the aqueous humor and vitreous humor will remain the same. The water, even the amount of water in the lens, will also remain the same, but something will happen such that we can be able to reduce or increase the amount of water in the path of light such that it can be brought to a focus either from a far or a near object. What will happen, we'll see. I'm sure by now we will have noticed that this lens kept on moving all along. So then we'll see that the lens can change shape. It can get more rounded or flattened so that we can accommodate. Let's look at the next slides.